So I was actually flipping through some old childhood photos this weekend, and I realized something kind of hilarious.
Oh, yeah. What did you find?
Well, there was this tiny, chaotic 3-year window where I basically grew like a foot and a half. I lost all my baby teeth, and I honestly couldn't walk through a room without knocking over a lamp.
Ah, the classic growth spurt.
Exactly. It was just this massive, concentrated burst of growth, and then I just sort of leveled out. And, well, here's where it gets really interesting, because it turns out the entire universe did the exact same thing.
It really did. And mapping out that universal growth spurt is honestly one of the most incredible detective stories in modern astronomy.
Which is exactly our mission for today's deep dive. We are exploring the ultimate biography of the universe's stars. We're pulling from the foundational Madau and Dickinson research, along with some wild new data from the James Webb Space Telescope.
Right, and we're also looking at a really fascinating paper by Hasselbauer and colleagues.
Exactly. And honestly, organizing that kind of chaotic, massive data timeline is tough. I mean, whether you are an astronomer analyzing terabytes of light data or just a business trying to optimize your systems, you need the right tools.
Oh, absolutely. Data is just overwhelming without the right help.
So true. That is actually why we love our sponsor, Embersilk. If you need help with AI training or automation or software development to uncover where AI agents can make the biggest impact for you, just check out embersilk.com.
So, getting back to it, if we are looking at the universe's baby book, where exactly is this massive growth spurt?
Well, it's captured in something called the Lilly-Madau Plot. You can think of it as basically the master chart of cosmic star formation.
Okay, like a giant timeline of when stars were born.
Exactly. And it shows that about 3.5 billion years after the Big Bang, which is a period astronomers call redshift 2, the universe was just functioning like an absolute factory.
Yeah.
Yeah, it hit this massive, explosive peak of star creation. But the wild part is that after that peak, star formation just steadily dropped off. Wait, so it just peaked and then slowed down forever?
Pretty much, yeah. I mean, half of all the stellar mass that exists today was already built by the time the universe was just a fraction of its current age, like before redshift 1.3.
Wait, I need to understand the mechanics here. Why did the factory shut down? Did the universe just, run out of the gas needed to make stars?
Well, not exactly run out, but the fuel became unusable. So think of it like a roaring engine, right? Early on, galaxies were flush with this dense, cold gas.
Which is the perfect fuel for making stars, I assume.
Spot on. But those massive early stars burned fast, and they died in these really violent supernova explosions. And at the exact same time, supermassive black holes at the centers of these galaxies woke up.
Oh, wow. So it just got incredibly chaotic.
Exactly. All that violent, explosive energy heated up the remaining gas and literally blew it outward. So it starved the galaxies of the cold fuel they needed to keep building.
That is wild. So the stars essentially choked out their own supply line. That makes perfect sense. But let me push back on this timeline for a second.
Sure, go for it.
Because didn't the James Webb Space Telescope just find a bunch of enormous bright galaxies forming way earlier than we thought? Does that break this whole engine model?
You would totally think so, but no. JWST didn't erase that massive peak. It actually just revealed a really spectacular prologue to the story.
Oh, I love a good prequel.
Right. It looked further back into the dawn of time and found that the very first galaxies were just absolute overachievers. They were burning incredibly hot and bright.
Which is amazing.
It is. And this actually solves a massive historical headache for us called the photon budget.
Okay, photon budget sounds like an accountant trying to pay a cosmic electric bill.
Yeah.
Give me the simple version of that.
Fair enough. So imagine the early universe as being filled with this thick, murky fog of hydrogen gas. To clear that cosmic fog, you need massive amounts of ultraviolet light to literally zap the gas and make it transparent.
Okay, so you need a ton of light to burn through the fog.
Exactly, and astronomers debated for years whether the early universe produced enough particles of light to do that.
Right.
Like, did we have a large enough budget of photons to burn away the haze?
And I'm guessing GWST finally give us the answer.
It did. Those surprisingly bright early galaxies were pumping out more than enough light to clear the fog. It perfectly balances the budget.
That is such a satisfying aha moment. So we have this brilliant early dawn clearing the fog, then a massive burst of star formation, and then things cool down.
That is the global picture, yeah.
But I was looking at the Hasselbauer research, and it seems like our own local cosmic neighborhood completely missed this entire narrative.
Oh, yeah, this is where the universe gets wonderfully weird. When we measure the galaxies closest to us, they tell a totally different story.
Really? How so?
Well, in a region roughly a billion light years across our local volume, the star formation rate is essentially flat. They completely skip that massive historical peak.
How's that even possible? Are our local measurements just flawed because we're looking from the inside out, or what?
You'd think it's a measurement error, but the math is actually solid. It points to a fascinating reality that the universe isn't a perfectly blended soup.
Okay, so what is it then?
It is much more like a lumpy sponge. Haselbauer's research suggests we are sitting right in the middle of a massive 5 gigaparsec cosmic void.
Wait, a void, like an empty space.
More like an underdense pocket.
Yeah.
We basically live in a region of the universe where things just evolved much more quietly.
Which is an incredibly inspiring thought for you, listening right now.
Mm.
If our local galactic neighborhood is just this quiet, slow-paced pocket of the cosmic sponge.
Right, just a quiet little cosmic suburb.
Exactly. Imagine what spectacular undiscovered phenomena are currently hiding out there in the bustling, densely packed regions of the universe.
Oh, absolutely. Human ingenuity has decoded so much of this grand story already, and honestly, we are really just getting started. It's such an exciting time for science.
It really is. Well, if you enjoyed this deep dive, please subscribe to the show. And hey, leave us a 5-star review if you can. It really does help get the word out.
Yes, please do.
Thanks so much for tuning in.